Hi, in this video, we'll discuss exception handling, an optional class which was introduced in Java 8. With this episode, we'll also conclude the Java series for testers. Before explaining what an exception is, I would like to highlight why exception handling is important. Since this is the last episode, it's connected with how we begin our journey. We started by understanding the basics like Hello World program and gradually built a foundation by adding variables, operators, and exploring the collections framework. From there, we learned how to create functions, design functionalities using classes and objects, and explored advanced topics like Stream API, Lambda expression, and method references introduced in Java 8. We also covered inbuilt functional interfaces and how these elements enable testers to create their own library or frameworks for testing. This helps to automate tasks such as finding bugs in an application using code instead of your manual effort. That has been the journey of this series. If you missed any earlier episodes or do not follow any specific concepts, feel free to leave comments. We'll work on improving the content. Now let's dive into exception handling and understand what an exception is. Think of exceptions like unexpected obstacles on a road trip. Imagine you're driving from one city to another. You have your route planned, but during the trip, something unexpected happens. Could be a flat tire, a closed road, or an accident. These unexpected events disrupt your smooth journey and needs to be addressed before you can continue driving. In programming, exceptions are those unexpected events, for example, invalid inputs, file not found, division by zero. All these operations could disrupt the normal flow of your application. You need to handle these events to ensure your program can continue running smoothly or exit gracefully. When creating a Java application, especially one that tests other services such as web services, desktop, or web applications, you may encounter scenarios where something disrupts the normal program flow. For example, as a tester, you might expect a user to enter google.com, but someone might mistakenly enter googleuniversity.com. Such deviations lead to unexpected behaviors. These disruptions are called exceptions. In simple terms, exceptions are conditions that interrupt your program's normal execution flow. Some of the exceptions that you will be encountering while you are going through this course could be division by zero, array index out of bound exception, null pointer exception. Your exceptions are broadly categorized into checked exception and unchecked exception. To go back to our analogy, now imagine that before you're starting your road trip, you do some careful preparation. You check the weather forecast, you ensure your spare tire is in good condition, you confirm the roads on your route are open. If there's a problem in your preparation, example, no spare tire or closed roads are on your route, you won't even start the trip. You fix these issues in advance to avoid getting stranded. In programming, checked exceptions are like these pre-trip checks. The compiler forces you to handle these exceptions before running the program. Example, IO exception, like ensuring a road or your file path exists before you start it. The SQL exception, like confirming your destination address, like your database credentials are valid. If you do not address these issues, your program won't compile, just like how you won't even leave for the trip unprepared. Then we have the second category called unchecked exception. Now imagine you're driving and something unexpected happens on the road. You hit a pothole and get a flat tire, someone cuts you off and you need to brake suddenly. Your GPS takes you to a wrong road. These events couldn't be predicted before your trip. You didn't plan for them, but they happen while you're driving and you must deal with them in the moment. So in your programming terms, unchecked exceptions are like runtime surprises. They occur while the program is running and weren't anticipated during the planning, which is your compiling stage. Example, your null pointer exception, like realizing mid-trip that you forgot to bring your phone charger. An arithmetic exception, like attempting to take a shortcut to a blocked road and realizing it is impassable. Unchecked exceptions aren't checked by your compiler. If you don't prepare for them in your code, your program would crash when they occur. Just like your trip might be ruined if you can't fix the flat tire. And there is another type called errors. Errors are like catastrophic failures during your road trip. Problems so severe that you cannot fix them on the spot and your trip must be abandoned. Example like engine failure. If your car's engine breaks down completely, you're stuck. You cannot fix it with a spare tire or basic tools. You'll need professional help or even abandon the trip entirely. In the programming terms, errors are critical system failures that the program cannot recover from. They're typically caused by issues beyond the program scope or logic. Unlike exceptions, errors cannot and should not be handled by the program, though in rare cases, advanced strategies like monitoring systems or restarts may help. Examples for your errors in Java are out of memory error, stack overflow error, linkage error. You can assume your out of memory error as the program running out of memory, like a car running out of a fuel far from the gas station. Your stack overflow error could be like an infinite recursion leads to a stack overflow, similar to the GPS routing you in a circle endlessly until you get lost. Or a linkage error, a critical dependency like your car engine is missing or incompatible. The hierarchy of your exceptions. The root class for your exception handling in Java is throwable. Throwable has two main subclasses. One is exception and error. Java provides three key mechanisms to handle exceptions. One, try block. A code that might throw an exception is placed in the try block. Catch block. This block catches and handles the exception. Multiple catch blocks can be used for different exceptions. The third, finally block. Code in the finally block is always executed regardless of whether an exception occurs. Throwing exceptions, throw statement and throws clause. So you use your throw statement when you manually throw an exception using the throw keyword. You use throw clause when you want to declare exceptions in the method signature using the throws keyword. Custom exceptions, you can create your own exceptions by extending the exception class. In Java 8, they introduced optional class to handle the presence or absence of a value gracefully. And why to use optional is to prevent null pointer exception, to provide improved code readability. By explicitly checking for the presence or absence of value, you avoid runtime errors caused by null. Optional will make your null checks more explicit and improves your code clarity. For example, here the get name from database method might return optional empty if no value is present, preventing a null pointer exception. Exception handling and optional class are essential tools for robust Java programming. By understanding these concepts, you can write better code that is both readable and resilient. The practical session will demonstrate exception handling and the use of optional.